Everybody runs. Well, good evening, everyone. This is a meeting of the Lowell School Building Committee regarding the building of Lowell High School project. In light of the fact that we have a pretty full agenda, I thought we will get started. We aren't taking any votes tonight, so whether there's a quorum or not, we're going to go through with the presentation. There's lots of information for the school building committee to have and digest as we move forward. We will be taking substantive votes in the future, and so this is building to that. For those, we did hear from several of the members of the committee who had conflicts tonight we will be getting all these materials to them so that they will have access to all the facts and the figures, without further ado, Heather, if you could call the roll.
City Manager Eileen Donahue.
Here.
Representative Ratty Mom. Mayor William Samaras.
Here.
Edward Kennedy. Rodney Elliott. Connie Martin. Here. Connor Baldwin.
Here.
Diane Trad. Michael Vaughn. Janine Durkin.
Here.
Marianne Bustede. Billy Joe Turner. Richard Underwood. Christine Clancy. David Beatty. James Cook. Marianne Bellata. Jay Mason.
Here.
Brian Barry. And Maria Sheehy.
Thank you. I would like to take a moment to remember our former colleague here on the school building committee, David Cunningham, who unfortunately passed away recently. He was a tremendous member of the Lowell community and was a great member here of our Lowell School Building Committee since he joined this a few months back. Was always anxious and willing to share his interest and expertise, and he will be missed. So if we can just take a moment to remember Dave here. Thank you. So we have as I said, a full presentation tonight. And I will turn this over to our consultants who are ready to present. You should have the slides on your desk, but we will also have it so people at home can see the presentation. So, Joe, if you can take it away.
Thank you. Tonight we're going to go through a number of items. We want to look at updates from the last school building committee meeting on September 6th. We have design updates. We were asked to look at pre-engineered building in terms of its cost relative to other considerations. We also have an exterior update to the exterior of the building. We have ongoing design options study with the exterior materials as well as the interior materials. And tonight we have our mechanical and electrical engineer here with us from Garcia Galusca de Souza, who will be talking about potential building mechanical systems. And then we'll be talking about next steps to our next school building committee meeting on November 1st. And we have announcements as our last item. So since our last school building committee meeting, as I said, the pre-engineered building was an area where we wanted to study more. There was some concern about how a pre-engineered building would look, and During our earlier study of the PSR, Preferred Schematic Report, the idea was to introduce a pre-engineered building on top of what was a traditional structure on the gymnasium. And it was an attempt to span a large space where we have, basketball and track facilities, and we were looking to try to get economy in doing that. So we were in touch with building manufacturers and also our cost estimator. And what we discovered is once you start to introduce anything beyond what is standardized in a pre-engineered building, you start to lose that efficiency. These systems are really designed to stand alone. As you can see, they are here, they're standalone on the site. And how you get that cost efficiency is the speed at which they're put up and the siding that's used as well as the roofing materials. As you start to introduce more customized and better materials to the exterior of the building and to the roofing system, you start to lose that savings. So we're seeing approximately $150,000 to $200,000 in cost differential there between what a normal construction would be and this. And when you start to introduce some of these improvements, that delta reduces. So it's our recommendation after doing this further study that we should discontinue with this approach and go to a standard construction. So we wanted to get back to you on that and explain our findings. And Dawn is going to take us through how the building has been developing over the last several weeks.
Thanks, Joe. Okay, real quick, I'm going to go through the exterior design, how it's changed since we last saw you, and this is just a reminder of the current campus configuration and where the design stands now. As far as the Freshman Academy, nothing's moved. Big picture, we're just refining the design. And as Joe spoke about with the pre-manufactured building, we decided not to stick to the geometry that particular building type requires and just went with a simple shed roof. So you'll see it a little bit better in some of the perspectives, but just wanted to point out that major change. Another thing that you'll see updated, we've added this sort of architectural canopy outside of the gymnasium entry that's twofold purpose. One is to provide shelter for students if they're waiting for whether it's the buses to take them to the fields at Colley or the parents picking them up, but also as a security feature that will prevent people from just wandering into the green space and sort of distinctly defining that line between school property and the streetscape. So those are a couple of the major changes. Just looking at some of the same perspectives that you previously saw, this is the Freshman Academy. We spoke last time about having sort of activating this elevation based on feedback that we got from the participants in the city. We still have glass at the stairwell in the center and then glass flanking the corners at the typical classrooms. We still have quite a bit of glass up higher than like someone might be able to touch because of the grade change and then where the floor elevation is. And I think that's it on that one. This one you can see the canopy better and you can see the south side elevation of the Freshman Academy and sort of the 4 stories of classrooms that are facing south. And then also the gym entry off of Arcan. This is a little farther down the street, closer to where we currently are, looking up Arcan and seeing, you can see the shed roof I spoke about and some of the geometry change. The idea there is that you'll see this in the pricing, but as we've currently designed it, this is cow wall for anyone that's not familiar with that. It's a translucent wall that is often used to allow natural daylight in without glare. So you can't actually see out, but it allows all the natural light to come in. So someone shooting a basketball won't have the direct sunlight. And then there'll be some pockets of glazing or cow wall that come down. So That's what you're looking at there. We also have opened up this corner and activated it, and you can, as you're coming down Arcan, you can kind of get a glimpse of what's happening in the gymnasium. And you can see the Freshman Academy in the distance. And then this is the front entry, and it looks a lot like what you previously saw. There's some minor changes. I can point them out quickly. We've got started to introduce a live roof, if you will, a green roof, a tray system. That's a single loaded corridor and sort of connecting to nature and building on some of the connection to outdoors that we're trying to improve here from what currently exists. And then also opening up the stairwells here for, seeing some of the vertical activity that happens instead of what currently exists as a big blank brick wall. And then this is the view from the canal side. Still some site improvements to work on. That's coming in the next couple weeks. But you can see the cafeteria and the connection to the canal, as well as the east-facing side. And we've sort of done, we keep talking about a blank wall, possibly for projection and outdoor entertainment. So we're starting to get glimpses of that as well. And then lastly, you can see we've currently proposed a 2-story bridge scenario. And there has been some talk that it may or may not be something that's well received, especially from the Historic Commission. So we've taken a stab at, you gotta watch closely, a 1-story. I'll go back for those who blinked. And there's the 2-story option, there's a single story. So we have it sort of figured out in either scenario. So if anyone has any thoughts on that, we'd like direction as far as how to price it for our schematic design. I will take you through, this is a perspective looking from sort of the end of the parking garage towards the 1922 building. And I'm sorry if it looks better on my computer screen always, but that's the perspective, and there's the single story, 2-story, single story. So, and this is in the proposed location for anyone who's interested. So, I don't know, we had had a conversation with the city manager. We'd like some direction if anyone has strong feelings one way or another. Yes?
Mayor Samaras.
Have you figured out bridges are very expensive. Sometimes people don't realize how expensive they truly are. What's the cost between the two-story? Is it significant, or could it be?
The cost of the 2-story is in the budget currently, so there would be savings if we went to a 1-story. It wouldn't be half because there's a lot of foundation work that has to be done, and we still have to have a roof, but we'd be reducing siding by half. So there is some savings. I
mean, I do like the idea of a 2-story bridge. I mean, it just helps movement within the school. It makes it thins out the grouping going through the tunnel at certain times.
Absolutely.
I think we really have to know at some point, though, the costs and things like that,
Okay. You hit on the reason that we've designed it this way. That was the feedback we heard in the user meetings and from the educators, that there's a bottleneck there, and the connectivity of really having an open campus was the reason that we had the 2-story to begin with.
The 2-story, I mean, it does make it safer. There's no question about that.
Does it make it safer, you're asking?
I think so. No, I
You're suggesting it does?
Yeah.
Okay.
No, thank you.
I think back early on in the spring of 2017, in the first Sustainability Committee meeting, we looked at a 2-level a bridge that had been done. It was an example in a publication that we reviewed together. You should have, I know Bob has a copy of it.
Yeah.
There were conversation and study areas alongside the walkway circulation pieces, and I thought it was very exciting as a space, and it not only improved circulation by having 2 levels, but it gave you some connection between the levels and some sort of places that opened up off the hallway for spontaneous conversation, studying. I don't know if that's possible with the sizes that we're talking about, and I'm not talking about budget. Obviously, it would be more expensive to go wider. But I know we did look at that, and I was wondering if that was in your thought process.
We did, I don't know if Bob wants to say any more, I'll say what I know. We had proposed a few scenarios early on, I think in the PDP or the PSR, where there were some larger bridges that had sort of study space, if you will. I think the feedback we got was that there was concern there wouldn't be adult supervision there from an educator standpoint, just so you know. But we felt the same way, and truthfully, if you went back and looked at our interview, our bridge it kind of had a curve to it, and it created this space where students can study and gather and do group work. So that has been something we've thought about, and I think based on the feedback we got, this is where we landed, where it's approximately the same width. It's just they're more open, more functional, and two-story in this case.
And one of the issues that Don's raised is to get some direction from the school building committee. Naturally, there's cost concern, and there's also concern with working with both the federal government and DCR and Article 97 issues. So we will need the direction as far as how we're going to approach getting whatever approvals or waivers, whether it's two-story or one-story. So, but starting first as a first level is what is the wish of the school committee if possible. So, Councilor Kennedy.
Thank you. Can you give us a rough estimate of what the difference would be in cost between a two-tier and a one-tier? I mean, it doesn't have to be exact, but you must have an idea.
We don't have those numbers with us tonight, but we will get those back to you.
Okay. And
We do have them, I just don't have them with me.
Okay.
I'm sorry to interrupt you, Councilor Kennedy. We don't necessarily need a direction now. As we've currently shown it and continue to design it, it's two-story. So, and we can present costs when we come back in a month and let you sort of think about it and talk about it, and then, you know, consider giving us direction then. But as it stands, we keep showing it as two-story, just knowing that there have been comments out there that say it's maybe not desirable from a historic standpoint.
Right, but you understand that in order for us to make a decision, we'll need to have a pretty good estimate of what the difference will be in cost.
Yes.
What about the exterior of the gymnasium, which I think the last time you were here was like you had just like a metal exterior. What have you done with that? Has that changed or?
Wait for it. It's right behind this. So you want me to move ahead into it? That's
I'll
literally
wait.
the next thing.
I came in a few minutes late.
No, it's fine. I haven't covered it yet at all.
Okay. Okay.
Councilor, I'm not sure whether you heard that they've moved off having the pre-engineered
Okay.
concept, and this will be traditional
No, I did not.
construction.
Let me just update you.
Sure.
Since I started that before you came in. We had heard what the committee had asked us to do, so we went back and we looked at that, and in the preferred schematic report, we were considering a pre-engineered building sitting on top of an existing, or not existing, excuse me, a new construction base. The advantage to that was trying to reduce cost. As we've got into it further, we realized the delta that we thought we were going to achieve there wasn't as great. In fact, when you start to improve the siding and improve the roofing, the delta that we had was somewhere between 150 and 200,000. And when you take the corrugated out and start to look at better materials, that delta comes down. So after talking to premier building, pre-engineered building manufacturers and our cost estimator, we don't think that the savings that we thought was there is there, and we made the recommendation this evening that we should go with traditional construction.
Okay.
As it relates to materials, I'm getting to it. So
Yeah, and as I pointed out last time too, I think that the corrugated looks good for maybe 10 years, 15 years, but then it starts to look tired, and I'm not sure that you can undo that, whereas different types of materials will probably hold up better over the long haul.
We actually agree, so we'll get to that. Thank you. Keep going? Okay, anyone else have any bridge? Okay. So design options, exterior material options. So I just want to take a step back. You've all seen this. These are precedent images from Lowell, things, you know, that show the range of architecture within the city of Lowell and specifically to downtown Lowell. Some of what we're trying to do architecturally is really knit some of the materials together. And I spoke about this last time a little bit, but I'm just reminding you that we've got the historic building with sort of the stone base and the yellow brick and the beautiful detailing there. And then we have the 1980s building, the facade, in which we're planning on keeping at least the brick pieces of it. These white, the failing panels that exist there will all be replaced. And the intent is whatever base is decided on the new construction to use that along the 80s building to start to literally knit together some of the palette of materials. Internally, we had a design conversation and talked about sort of how especially the Freshman Academy has a real civic and municipal presence on the corner of Father Morissette and Arcan, and just thinking about sort of what that building type looks like. I've shown the building we're in, the beautiful City Hall, your new courthouse, and then not far from our office, I walk by the Brook Courthouse daily, and it's such a beautiful example of how a civic, simple design can really be timeless. And those are some of the things we think about as we're looking at materials and facades. So I just wanted to share some of what, behind the scenes, what we talk about, and then get into the materials and the logistics of the materials. You all have this in your packet. I'm not going to go through everything, but you asked us to look at the costs, especially against what was carried in the preferred schematic, and that's forthcoming. But this is literally the durability, the estimated cost of each of the materials, the maintenance rating, like is it high maintenance, is it low maintenance, and then the typical life cycle. So we've given it all to you. I'm not going to go through everything, but one thing I do want to point out, I previously had real stone on here, which I think would be cost prohibitive, but have added a CMU option that wasn't previously on there. And there's different than the split face that exists at the current building. There are a lot of options that this one's polished and has a real stone feel to it. This one's got a texture to it, semi-polished. And there are some real nice examples of like an upscale CMU. So that's been added to the mix because, as you can see, it's pretty cost effective and is nice and durable for a base material. So that's different than what you previously saw. And then these are the facade materials. I kept the corrugated on there even though it didn't make the cut for any of the options tonight. Phenolic and fiber cement. The PSR, what did we carry? Collectively, between the Freshman Academy and the gymnasium, because we're going to use those as like a snapshot in time for what the cost was at PSR and what it is currently right now, recognizing things will change. The windows may get a little bigger, a little smaller, different configuration. Keep that in mind. These costs are literally this snapshot in time. But this is here for comparison. So the Freshman Academy was just a little over $1 million. Gymnasium was about 1.5, with the total being about 4.6. So that's some perspective where our budget is. Option 1, I've shown a couple different images for each, so I will just explain what they are and then go through the images. In this scenario, we have the polished CMU base, which I just spoke about, and then a brick facade. And for the sake of conversation, I've shown these colors, but know that color is irrelevant. We can get to that later. It's not about the color, it's about the material and about what we will carry for the schematic design. So just all of these shown in different options. In this particular case, the gymnasium still has the 10-foot base, and then the brick above, and then above that's the translucent cow wall that I spoke about. So that's option 1 with a polished CMU base and brick facade. And the cost of that is included here. The Freshman Academy, as it currently, snapshot in time, is shown, is $2.5 million. The gymnasium is about 1.8, and you can see the deltas from the PSR right below them. So in this case, the Freshman Academy is about $600,000 less, and the gymnasium's more. You might say, why is it more? Some of it has to do with the pre-manufacture that we spoke about and offsetting some of those costs, but we're still, as you can see when you get to the total, about $200,000 below what the PSR budget was. And for reference, the PSR budget carried a brick base and a metal facade. Option 2 has the same brick facade, but the simulated stone, which I know there was some desire, I'm going to hold it up to see, sort of the nod to the historic base. And again, color, we would match it pretty close to what's over there if that was the desire. So this is here just for reference. But the simulated stone base with the brick facade, and again, you can see it in all the views. And the cost of this, the Freshman Academy is about 2.6, the gymnasium's 1.9, so the differential is negative 500 on the Freshman Academy, about plus or minus 510 on the gymnasium, so it's basically on the budget. It's within $7,000. And then lastly, there was some desire from the working group to see the phenolic facade on the upper facade. So again, I've shown the economical CMU base, and in this case, to offset the differential of cost, because this is about 20, give or take, dollars per square foot more than a brick facade. In the case of the gymnasium, I'm gonna scroll through all the different options so you can see the Freshman Academy. But in this case, we carried, instead of, in the other cases we had brick on the gym, this would be all CMU to offset some of the cost. So because the CMU is so much more economical, we're trying to save some of the additional $20 a square foot of the phenolic. And in this scenario, it's about $3 million for the Freshman Academy, 1.6 for the gymnasium, and landing at 4.7, which is within 200,000 of the budget. So these are all options. We'd love to have some direction. It doesn't necessarily have to be a vote. It could just be a preference, because we need to show something for schematic design and to be able to carry the design forward as a budget. So,
Can I ask a question, Don?
Please.
So option 1, and that's the brick with the polished CMU.
yes,
Is that the least expensive?
it is.
Okay, I like that one. I actually do like it.
I do too. This, if anyone, we could pass it around, or if you want to come up and touch it, this is the polished CMU. And then this is one of the lighter bricks we had in our office. Again, color is, you know, it can be, we can talk about that later. I also have close to what is existing, if anyone is interested. We've got the 1980s. Oh, sure. Yep. Why don't I give you all of these? Here you go. You're welcome.
So I know this isn't a formal vote, obviously, and it's
Right.
just to try and give the team some idea, as we did the last time, where as a result, we don't have the pre-engineered gymnasium tonight. So I guess I'll start. I actually do like option 1. Colors depend, you know, obviously to be determined, but
Yeah.
I mean, it is the least expensive, but I also think it's, just my view, I'll just throw it out there, the brick and the stone is kind of in keeping with the architecture of the city, but, and yet you still have the kind of contemporary feel to the
Right,
to
you
the
want me to go back?
gymnasium with the shed roof and the design of the Freshman Academy. So I just throw it out there. I don't know whether anybody wants to weigh in to give these folks some idea of where they should be pricing. I mean, they're going to need at some point settle on one thing to come up with a total package of pricing. So that's where I'm coming from.
Can you tell us a little bit more about the phenolic facade?
The design or the material?
The material?
Okay.
What is it? Did you pass that out?
I did. Those were the 3 squares. Yep, these ladies are
The
holding
little
them.
squares?
Those are just different. You can get it solid,
But it's
wood.
all the same?
It's all the same.
Okay.
So again, color is to be determined later, but that is what's called a rain screen. And honestly, every material up here is somewhat of a rain screen. The way construction is built now, you basically build the sandwich of the wall, and then you have a hanger system, and then the facade is applied, versus the 1922 building where the masonry is literally holding up the building.
Yes.
A white wall, if you will. So the brick is also a rain screen where water is allowed to get out, you know. So that is it's basically on a Z-girt system, and it's applied. You can either have a concealed fastener or a face fastener. And I think last time we were here, we showed a few examples where we've used it recently. So I'm happy to reshare that presentation if that's helpful.
Well, just, why might we like that?
It's
What are the
very
advantages of
durable.
that? Yeah.
It's very low maintenance. There's no joints to repoint. There's, it basically is maintenance, I don't want to say maintenance free, but you can actually take a panel off if something were to happen. But the core of the phenolic, the how it's made, is very highly durable. So it's a little more contemporary of a material. It's been used in Europe for probably 50 years. Very popular over there, and is popular around here now. We've used it on a few projects.
Okay,
And
thanks.
you're welcome.
Samaras?
Okay, when you talk about the brick facade, of course, you know, all our buildings are real brick, solid brick. What's the, I mean, you gave us some information, but is there a real decent life expectancy in the brick facade? I mean,
Sure, I can go back to that slide. I think it's, I mean, we listed it at 75 years.
Yeah.
And the maintenance is periodic resealing, power washing, and repointing. So as you know, bricks, you know, whether it's a white wall or a veneer wall, they need some sort of maintenance at some point. You're dealing with it a little bit now with the roof parapet over in the 1922 building. The joints can fail, the bricks can crack. But that's typical whether it's, you know, older construction or newer construction, like the joints need maintenance.
well, it just seems that, you know, with real brick, I mean, unless water gets behind the brick and then the winter, the ice, I mean, it can blow it away, so to speak, but it doesn't really require as much maintenance the way I feel, or should it have the same maintenance as, we'll say, the facade brick would? You know what I'm saying? I'm looking at, there's a long-term cost too. I mean, because sometimes the cities, we just don't have the money to do some of the perfect maintenance that, and we've proven that in
Sure.
a sense.
I was going to ask Joe to speak a little bit about the construction and how that works with the water and.
So the way brick walls are constructed today, far better than the walls that were constructed 100 years ago. And we oftentimes think of, you know, how stout old buildings were, and they were for their period. The technology was you put one piece of material on top of another, and you get really wide at the bottom, and at the top you get narrower. Today, all that load transfer is done with structural steel primarily in this case. And the insulation that you really didn't have in, say, the older building is put on the outside of the building. So you do that so that you control moisture and you control mold growth. And that's primarily where insulation is provided today. So from usually what you will have is a metal stud, a heavy gauge metal stud that's designed to take the wind load. You have an exterior gypsum product with an air barrier over it. Then you have your insulation. And that will range anywhere from 4 to 6 inches of insulation and a girt system that ties back either a phenolic panel or a simulated stone or CMU. They're all pretty much designed the same as Dawn was speaking about. So the difference really is the veneer piece, you know, and where you see the maintenance requirement in brick is that every so often, 30 feet plus or minus, you need what's called a control joint. And that control joint is oftentimes a caulking joint. So every, you know, somewhere between 5 to 10 years, caulking joint need to be replaced. Sometimes they aren't. in the event that they aren't, you know, more water than you were anticipating can get into the system.
Yeah.
The fortunate thing about the way we build walls today is if moisture does get in the form of vapor, it has a way to get back out. It's flashed out at regular intervals, and they're designed to actually, that's why they call it a rain screen. It prevents liquid moisture from getting in, but allows vapor moisture to find its way out. So when we speak about having to reseal a brick wall, it's not resealing the entire wall, it's resealing these joints that happen throughout the wall system.
Okay, when the city manager talked about option one, how do you feel, your own feeling as far as that type of wall being durable and cost effective? What's your feelings on that?
I think a brick wall and CMU wall is very durable. I think, or simulated stone. It requires a little bit of maintenance. It's not huge on the maintenance side, with the sealants that need to be looked after over time. The difference in the phenolic, as Don was pointing out, is that a lot of these joints are open joints, so we don't have sealant, and therefore there's less maintenance over time. That's the delta there in terms of the two materials.
Okay, thank you.
Sure.
You can,
Okay.
I'm sorry, Mayor, I just want to follow up on this. You can see here the brick has a very high
Yes.
durability, as well as the CMU. So that's important to notice. They're all medium as far as maintenance is concerned, just because of everything Joe just mentioned. And then brick with a 75-year and a 50-year assumed lifespan. I mean, that's some of the most durable, longest lasting materials.
The thing is, we want to maintain our costs as best we can. I mean, the people, they're watching us, they want the high school, but they'd like to have the high school built for, we'll say, a very little amount of money.
I
It's
understand.
going to be costly. But the issue is, if you made the transition to real brick, I mean, there's definitely, the whole idea that this high school is going to be there for the next 50 to 75 years, that's what we're looking for. I think most are looking for, say, 75 years. Is it worth it to make that transition to spend a little more? Or do you think it's such where we could be relatively safe with?
It's hard to say, but
I mean,
I think with-
I'm answering my own question in the sense of
Yeah.
brick is better, we know that, but the thing is, there's a difference, that difference in price, is it so significant that we shouldn't do it, or is there a possibility that
if,
it would work out?
do you want my opinion? I'll give you my opinion.
Sure, that's what.
This is the most economical, option one, which the city manager favors,
Yeah.
is the most economical, which is truthfully why I showed it. I'm reading the city and knowing that everyone's wanting to stay on budget, and that's why it was shown. For me, I would carry brick and brick, which is basically the same price as simulated stone, so that you have some flexibility. That's basically on budget. It's in par with what we priced. It's within $7,000. And the simulated stone and brick is essentially the same. It's $48, and the range is $35 to $50. Just so that you give yourself a little bit of breathing room, so you have some play. If you can always go to option one.
Yeah.
And then you receive the savings that you could maybe spend somewhere else. I don't know. I think about it as, don't always choose the most cost effective off the bat, because you never have any wiggle room. But that's just my 2 cents. It's your
That's the
building.
point, that's what I'm trying to raise.
Yeah, so I guess that's why I'm answering it that way, and truthfully, it's just my singular opinion, is that if you carry something right at the budget that allows you a little bit of flexibility, we always know that we can go to option one. If it's the most preferred visually, or if it's the most preferred economically, it's there.
Okay, could you give us, in other words, next time, have that as part of the presentation again,
We can, it's sort of commentary, it's my own 2 cents.
but
Maybe
the
my
thing is-
team disagrees
but-
with me, but.
I like the commentary, so
Okay.
I'd like to see it.
Sure, I mean, we're here to provide recommendations based on what we've done before, and I certainly don't, I tried to show options that made sense and that I understood as, something below the budget, something on the budget, and something that we were asked for that's maybe a little bit over the budget. Doesn't mean we couldn't, change the design to get it on budget.
The thing is, the city manager is looking at it correctly, but I think I'm looking at it a little bit as the principle. Do you know, what would I want?
Yeah.
You know, and, it's basically what can we afford, and is it the right way? Is it the right, it's what we can afford, and is it the right direction?
Well, as a suggestion, if you carried brick and brick, that would give you the most, you would be on budget. It would give you flexibility. You carry a VE item, a value engineer item, to take the base to CMU, that takes you basically to option 1. So that we know once the cost estimate comes in, if it's over, that saves us, what did we say, 200,000-ish? Then that's a VE savings, and people like how it looks. I don't know, just a
Thank you.
suggestion.
Thank you.
Madam Superintendent?
Thank you. The three of us at the end of the table were also liked the option 1, the look, because we felt that the brick was definitely more in line with, the rest of the facades of the building. However, I'm in agreement with the mayor that it may be worth looking at, the actual real brick to see comparatively if we could do it. I'm not sure if my colleagues feel the same, but.
Are you asking to do the whole wall out of brick, like old construction? Like a white? Is that what you were asking? Because I don't know that we even do that anymore. It wouldn't meet the energy code, which we're required to design to. Okay, I don't think I understood that. I'm sorry. It wasn't until Janine said that. Okay, so that's not an option. There's no insulation. So you will have a very drafty, cold building, and honestly, they wouldn't even allow us to build it that way because it doesn't meet code. So how Joe described it with the structural steel, the heavy gauge stud, and the veneer system, it's not that thin. Is that what you're asking? How thin that piece is? That's just a sample.
Yeah.
It's a real brick. It's 4 by 8, but yeah. Okay. The veneer is a full brick. That's like, so I don't break my shoulder carrying samples around. But it's a full brick, if that's your, because the old building.
That wasn't clear. Thank you.
Yeah.
Okay.
Councilor Kennedy?
Yeah, I'm with the city manager in option 1. That's my preference right now.
Okay, so maybe we can keep going?
Sure. Okay, interior materials, this hopefully will go quickly. We're making recommendations here, and truthfully, when I went back and looked at the PSR and what we carried, it's almost identical to what we would have proposed. So these are materials we're using all the time in public high schools in Massachusetts. So these are recommendations based on the room type. So for typical classrooms, we would propose a high-performance ceiling tile. It's got great acoustics. We need to meet a certain acoustic value that allows, a nice environment for students to learn. And the tried and true ceiling tile that we use has really great acoustic values. Painted gypsum walls. It's important to recognize that 4 of these walls will have teaching surfaces, and 1 of them will have quite a bit of storage and casework. So not all wall surfaces are exposed. So that's important to note. There is an upgrade to go to, say, an abuse resistant, and maybe we make decisions strategically to put that in certain highly exposed areas. But a typical painted gypsum wallboard, you can see it's less than $1 a square foot. And then we've been using linoleum floors. We had this conversation at the working group and proposed VCT linoleum and rubber, and we spoke to some of the benefits and downsides to them. Linoleum's pretty reasonable from a cost standpoint, and maintenance, it's really much easier than VCT. So, and from a price standpoint, it's not a whole lot more expensive if you don't have a moisture problem. Or if you do have a moisture problem, they're basically in line with each other because you have to mitigate the slab and the moisture with VCT, or else you get popping because of the glue.
Maybe we can pass
VCT?
maybe we can just pass that card.
Yeah, sure. Bob's asking what VCT is. He just threw me a softball. It's vinyl composition tile, which is basically the 12 by 12 tile that you see in almost every school around. Thank you, Bob. Sometimes we get caught up in the language that we speak, but VCT is very common. You've got all 3 of these materials basically over in the high school because there's such a vast range of different materials there. But this, from a maintenance standpoint, makes a lot of sense. We would also propose that in the corridors. I've switched slides, but it's some of the same. So the linoleum tile in the corridors, painted gypsum wallboard with, and we're proposing a porcelain wainscot. That's what we carried in the PSR. It's durable, and we often do what's called a Schluter strip, which is basically a metal corner and top and bottom so that the corners are protected. But it's a wainscot, it only goes to 4 feet. He's throwing me softballs. He asked me to explain what a wainscot is. So it would only be, it's like the wood in here, it only goes to a certain height, right? And then above it would be gypsum, just painted. And then again, the high-performance acoustic ceiling tile.
Councilor
Excuse me.
Kennedy?
Yeah. Thank you. I think when we're choosing the materials for the interior, that we should give some thought to using materials that we can use in other schools. Mm-hmm. It seems to me that if we ever get into a position where all our schools are where all the deferred maintenance in all of our schools is all up to date, that it would be economical and smart if we use the same materials in each building, each school building. And I think it's easier for the people, for the maintenance people too, if they're dealing with the same materials and products all of the time. And also, it would allow us to keep an inventory, and so to be able to do those repairs. We're a long way from that right now.
Sure.
But given the scope of this project, I think some thought should be given to doing that going forward when we're considering what materials to use on the interior of this building.
That's a great idea. Thank you.
Thanks.
And we're happy to continue that conversation. Gymnasium, we've got painting the structure. It'll be steel, painted steel with some acoustic panels on the wall, painted CMU walls, so durability in that space will be critical. Possibly some wall pads as needed, for overrun for the basketball and or off the track. And then sports flooring, multi-purpose sports flooring with a wood floor inlay for the competition courts. And again, this was all priced this way. So this is what we typically see in a high school in Massachusetts. Restrooms, seem silly to talk about restrooms, but they're important, and they're a place where vandalism happens, and it's important to talk about. In those cases, we do drywall ceilings for security. We don't want anyone popping a hidden camera or anything like that. So we typically do a painted drywall ceiling. We do painted CMU walls, and in this case, epoxy floors, which is a poured floor. It doesn't have the grouts, which require maintenance, and the cracking of the tile. We spoke with the maintenance group at the user group meetings, and they seem to be on board with this. We've done this in quite a few schools and have had great results. For example, the city of Newton only puts these in their bathrooms in all their schools. So this has been an effective way to keep the maintenance low in the restrooms. And the smells, for what it's worth. The grout really can hold smells. And then typical stairwell finishes. Again, painted CMU walls. Typically we do epoxy in the restrooms and the stairwells. At the very highest, we might do acoustical ceiling tile or just paint it. And then rubber treads and risers throughout the stairs with painted handrails and guardrails. And lastly, the cafeteria. Again, a lot of the same. The porcelain wainscot we'd propose, and that gives us some flexibility as we continue the design if there's something else that is preferred, but that's a nice, there's not a lot of wall in the cafeteria for what it's worth. There's a lot of glass, and there'll be some walls, but you have the servery and you have it open to the servery, so where there are solid walls, that's a nice solution. And then the linoleum floor again. And that's all. If anyone has any questions on interior materials or any thoughts. Great.
Thank you.
Thanks. I guess at this point we'll turn it over to Dominic. Here you go. You're welcome.
So I just want to, Dominic Pinello with Garcia Gillespie D'Souza Engineers. Just want to give an overview of the HVAC design and what we're working on through the schematic design process. We're in the steps of doing what's called a life cycle cost analysis, a comparison of at least 3 different options. In this case, it's 4 different options, and it's going to be versus your code baseline system. So that way we determine how energy efficient the different systems options are in comparison to the code. So the baseline system is what's called a VAV, a variable air volume system. And what it does is essentially uses air as a means to do your heating, ventilation, and air conditioning. There'd also be some perimeter radiation heating, but all the air conditioning is done by the airside system. Option 1 is called a displacement ventilation system, and it would have some radiant heating and cooling. So it's essentially a hybrid system. We're doing what's code required for ventilation through ductwork, and then the additional supplemental heating and cooling is done by hydronic, hot water and chilled water. Chilled water to provide the cooling, hot water to provide the heating. So typically a much more efficient way to do it because water is a more efficient means of providing that air conditioning. Option 2 would also be a hybrid design, but instead of just using displacement ventilation, which I'll get into, we're using a device which kind of has taken over what fan coils used to be. So it's a chill beam. I'll have a slide on that. And then option 3 would be what's called a air source VRF, variable refrigerant flow. So instead of using hot water and chilled water, we're using refrigerant-based equipment to do the heating and air conditioning. And option 4 is another take on the VRF system, but instead of using air-cooled equipment, we use water-cooled equipment for some improved efficiency and a little bit more durable because we're getting some of the equipment outside of the environment and bringing it indoors. In comparison to the existing HVAC systems, these will all be, more energy efficient, greater thermal comfort, just some of the problems that we've seen with the existing schools. Systems are old, even systems that are relatively new are failing. We could see here, between the 1922 building, it was an old steam heating system, very poor, inadequate ventilation. The newer 1980 building, even in the 1990s, some of this equipment's been replaced, but it's failing. We got little hot water boilers on the side of air handling units. They're maintenance intensive. They've got to get replaced every few years. So it all leads to low energy efficiency, high maintenance, inadequate ventilation. What we've heard too from the working group is poor filtration and expensive to change what filters they do have. And many of the areas do not have air conditioning. So any of the new designs would be proposing air conditioning. And it's also an antiquated control system. So all these HVAC systems that are controlled, they tend to fight one another based upon our study and talk with the facilities. So the goal of any new system that, the one common point to all of them, or the common points to all of them will be improved indoor air quality, improved level of filtration, very high degree of energy efficiency, high degree of thermal comfort in both air conditioning and heating seasons, low noise operation, which helps to a better learning environment, and they will all be connected through a new automatic temperature control and building energy management system. It's no longer just going to control just the HVAC. As Carlos will mention, it's an integrated approach now. So option 1, the displacement ventilation system. Another common point to all these systems, they'll have what's called a dedicated outdoor air system. So all the fresh air for the classrooms and office spaces will be 100% outside air, ventilated, filtered, tempered, and it also have a means of energy recovery, so we're not wasting energy. Any exhaust air will be delivered back to the unit. We'll have an energy recovery device. It'll be used to preheat or pre-cool the incoming outdoor air. Displacement ventilation is a little different than your common HVAC distribution systems in that it turns everything upside down. Instead of supplying from the ceiling level and trying to mix the entire room volume, we're supplying very low within the space at a low velocity, and in turn, what happens is the slightly cooler air comes into contact with heat-generating sources, people, lights, equipment, and warmer air rises, so as it comes into contact, that air rises, and that's why it's called displacement. That air is displaced. The benefit of that is that along with that displacement air, pollutants are removed. So what we're trying to show here is a typical mixed air system. All those pollutants would be mixed around, and the old saying is dilution is the key to pollution. So you keep introducing outdoor air, trying to dilute. Here what we're doing is introducing 100% outside air and then using displacement air to remove pollutant. The other benefit of it too is because it's slightly cooler than your room set point and the heat is rising, it sets up what's called a thermal gradient. So it'll be slightly cooler at the floor, and then you're trying to control for the occupied level, but up above where people are not occupying the space, it could get warmer. So that allows us to reduce our equipment sizes because our cooling loads are less. So that's a benefit of that. Low velocity, low noise, great. Humidity removal because of the dedicated outdoor air system. We don't need VAV reheats. That's common to the older systems, and very high ventilation effectiveness. The cons is that it does require some more costs for the radiant heating and cooling because that air is not going to do all the cooling or all the heating. Option 2 is the chill beam system, which I mentioned kind of took over the fan coil unit market. Within the center at the top right, that's where the primary ventilation air, so it would still have that dedicated outdoor air, 100% is supplied within there. And that essentially took over the fans action of each of these individual fan coils within the space. It's one, or we would zone them per classroom wing or multiple units, but there would not be, it's not like the old days where each room would have its own fan coil. This would be serving a wing or a section of a wing. And what happens there is that airflow causes an induction effect within the room. So that airflow is returned back through the return and then is heated or cooled. So that's the additional heating and cooling that's needed to maintain the space temperature is done by a hydronic system. Either hot water or chill water is run, depending if we need heating or cooling. So the pros of that, again, dedicated outdoor air, high energy efficiency, high indoor air quality, relatively low noise because we don't have a fan within the space, relatively low maintenance because we don't have a fan in the space. Some of the cons, because we've got more piping within the ceiling, requires some increased coordination. Because there's a cooling coil right there within the space, we've got some additional condensate drain maintenance, but nothing that we haven't overcome before. So these would be the plants for option 1 and 2. They'd be a high efficiency hot water heating plant and a high efficiency chill water plant. And what we're proposing is for the 1922 building to have its plant, and then the 1980s building, Freshman Academy, the additions, to have their own plant, so we're not crossing the canal. The other benefit of that is it reduces pumping energy. They'd be more central to those buildings served. And then another feature of the chill water and hot water plant design would be redundancy. We're not just going to have one boiler, one very large boiler, or one large chiller. We've got multiple, and that'd be based upon some redundancy. The pumps would have a redundant feature, and then both of them would have what's called VFD, variable frequency, or also known as variable speed drives. so that we're flowing hot and chill water based upon the actual demand of the heating and cooling systems to save energy. So option 3, very similar to that chill beam system in that there'd be terminal units within the space that would have, now these have their own small fans, but they're very energy efficient, very quiet. And instead of the hot water and chill water, it's a refrigerant-based system. So instead of hot water, chill water piping to each of them, there's refrigerant piping to each of them. And the benefits here is really about getting into your site efficiency. It would be more of an electric-based system than an electric and gas-fired boiler. This would use the same to do heating and air conditioning. Would be the same equipment. It would be an air source heat pump. There'd be multiple of these units. Because of the amount of refrigerant, we're limited to how much we can run within the area served. So there would be, instead of one plant, there would be kind of groups of air source heat pumps throughout the building. Just some of the pros: lower piping costs. The refrigerant piping is less expensive than the hot water, chill water piping. You don't need the boiler or chiller plant. That single cabinet could be used for heating and cooling, and it could provide simultaneous heating and cooling. So if you have a milder day, and for instance, the chiller plant might have shut down, but if you have the VRF system, you could provide cooling on that day. High energy efficiency, and with the all-electric, there'd be no site emissions if there was all-electric. The cons, there are some cons. There's individual motors within the space, some additional maintenance associated with that. Similar to the induction, that'd be condensate drain maintenance that would have to occur. And there is, while there's that no site emissions, there is slightly higher electrical energy use because you're heating with electricity versus natural gas. So the cost might be a little bit higher for heating. But we'll fully determine that through the life cycle analysis. Option 4 is just taking that. Instead of having those air source heat pumps, we add a cooling tower, and then it becomes a water-based system. From within the building, everything is very similar to option 3. So I'll turn it over to Carlos to talk about the building automation system, but just wanted to say, these are the systems we're doing energy modeling of and cost estimating in terms of maintenance and estimated first installation costs. And really what we'll be bringing back to you is the results of that life cycle analysis over a 30-year period for these buildings. And, I guess the feedback we would like is just, do these options seem like good ones to you? We worked with the working group, and that was kind of the feedback we got. But if there was anything else, any comments that we could take back, we certainly would like to hear.
Councilor Kennedy.
So you must think these are the 4 best, right, options?
They're 4 very good options.
Okay. They're the best is there an option you didn't give us that you think would be better than these?
No, these would be the 4 that we'd recommend.
Okay. And so out of the 4, which do you think is the best? The option 1?
Not necessarily. I think we've got to really do the full life cycle cost. Option 1 definitely has its benefits. We've used it in a lot of school projects because of the lower noise levels and the increased ventilation effectiveness. That's been very good options for that.
When do you think you'll complete the full life cycle analysis?
Correctly, I think it was November 1st was our presentation meeting.
The next time we meet? Okay. I guess, when I look at these, I'm paying more attention to the cons than the pros, just because of the situation that we find ourselves in now. So the one that has the smallest list of cons, to me, is the best just at first glance. But it sounds like you're not really looking for a recommendation this evening or some direction this evening. You just want to present this and then we'll be able to make a better decision after the cost analysis is done.
I think that's generally correct. Just if there were a system out there that, someone knew of or had a question about, we would be here to give comment on that.
Okay. I guess what I think is that option 3, for instance, just seems to have a lot of moving parts to me, or just that there seems to be a lot of areas where it can break down. And again, it's just, I think we're all concerned about the heating system breaking down just because of the way the high school is, and this will be a brand new and different. But looking at it, in the mayor's comments minutes ago, we're looking at this for now, but also for how's this going to look 15, 20 years down the road. So, okay, I'm sorry, go ahead.
Oh, thank you.
Mr. Nutter.
I just want to, agree with Councilor Kennedy from the little side conversations. If you could concentrate on 1 and 2, options 3 and 4 just seem to have so many moving parts, so many variables, and so much more required maintenance that it just looks like the first 2 options would be the preferred things that we'd like to see.
Well, we owe it to you to study multiple options, so, I think that's what the life cycle will likely show, is that the maintenance costs for those options are higher. Because, like I said, if you've got moving parts and a fan within the space, that does get accounted for differently than something that, only has an open and close valve. So.
Yeah. Just in, Mr. Mayor.
Just say we have extreme cold weather. The first options where it's more radiated type of heating, I mean, do they react well in extreme weather, extreme heat, or extreme cold?
All the options would be designed for a 0-degree day, approximately a 0-degree day. I think it's like actually 5 degrees per the energy code, okay. But that's where they would be designed, and they'd be designed to maintain within the classroom 70 degrees on that degree day.
Okay, so basically, I mean, we're safe with all the options.
With all the options, there would be heat, and as I mentioned before, for the first options, the boiler plant, it'd be a redundant design. So if one failed, we would not lose the whole capacity. We would do the same thing for option 3 and option 4 with what's called the VRF heat pump units. Yeah. There would be some redundancy to those as well. So if you lost one, you're not losing your entire system.
Okay, thank you. That's good.
You're welcome.
Thank you. So you'll come back with some pricing on all of them, but I do echo the sentiments that have been expressed here. As the office where we get calls about maintenance, I started getting palpitations looking at all those units. So the simpler the better, efficient, and of course, cost effective. Yep. So thanks.
No, we appreciate the feedback. Thank you.
It's on? Okay. Well, on the life cycle costs, we look at 30 years. So when you look at the compressors on the outside, we look at a compressor replacement as part of that cost. So it's capital cost plus maintenance over that 30-year period. Okay, building management system. Dominic talked about automatic temperature controls. So what we do in this building is we're going to monitor and we're going to control not just temperature, it'll be temperature, we'll look at humidity as well, and we'll look at CO2. So if I'm a teacher, I walk into my classroom, my lights will come on, automatically my occupancy sensor will go off. Lights turn on, there'll be a daylight sensor so that if it's a bright sunny day out, my lights will dim, right? And then that's it. Basically, it's all automated, and the temperature will be what the occupied set point would be. If I leave my classroom for a period of time, what will happen is I'll go into a standby mode. So instead of the temperature being 75 degrees in the summer, we may bring it up to 78 degrees in the summer. So we're saving energy there. The lights would go off, and that would be it. And then we're always looking again at humidity, and we're looking at CO2. So if there's nobody in the classroom, the outside air will go to a minimum position, so it'll almost be off. So we're saving energy. Ventilation is about 40% of your energy in a building. So that's where we try to get the most robust system and control. Dominic mentioned energy recovery. That's true on all of the systems that was mentioned. So we have this building management system, but we don't just do automatic temperature controls. We actually like to do more things than that. We like to have lighting controls. So lighting controls will all be integrated into that system. So schedules will all be the same. You don't have to do multiple schedules to set a room into occupied mode. And the other thing that we do is we monitor water. If we have gas in the building, we monitor the gas usage. We take the emergency generator and we tie that into the building management system, so now we can monitor when it runs, how long it ran, and the parameters that it ran at. So all of that is tabulated, and we even do the simple things like the fire alarm system. Fire alarm system goes off, that tells the building management system, hey, there's a fire alarm this day, lasted this long. There might just be a trouble in the system, so it'll actually know what the trouble was and where it is. So it's also used as a maintenance system. The other thing that it does is, and I don't know if Lowell uses programs such as School Dude, but you can actually set a program. So on School Dude, they have scheduling. You can set a room to be occupied like this room, 6:30 to 10:30 tonight in the school. You go into your School Dude, whoever that person is, sets it up. And the building management system takes that schedule, automatic populates everything, and it's done. So it's a building management system. Can you click the next one? Another source that we're looking at for energy is obviously on-site renewables. We started looking at PV or photovoltaics. So we looked, what would be the maximum amount of photovoltaics that we could actually put out there when we look at orientation of the building, and we look at loading of the building, and just structure of the building. And we're still working on this. So this is what we looked at present, but there may be some other structural issues that we haven't looked at yet. So we're looking at a maximum KW array of 334 through all the buildings. And that would generate approximately 386,717 kilowatt hours per year. That would also save us approximately $684,310 and give us 2 lead points. So that would also be brought into the energy management system, so that we can see how much energy we're using, how much we're producing. And that would all be part of a building dashboard system. So this would actually be displayed on the building. Another system that we don't have anything on, and it actually depends on the life cycle costs, is we're actually going to look at a cogeneration system as well. And what that is instead of just having emergency generator or generators basically waiting for power to be down, we would run those generators continuously. So we would be producing electricity, and then we take the heat from the generator and we would be heating the building in the winter, or we'd be cooling it in the summer through an absorption chiller. So that's another system we'll look at, but we can't do that one until we do the life cycle costs. That's it.
Any questions? Councilor Kennedy.
I think the last time you were here on the roof, you had some vegetation and other things. So with this, would there just be solar panels on the roof and nothing else, or would just a portion of the roof be dedicated to solar panels and part of it to other things?
There would be other things on the roof as well. There'd be mechanical equipment, so we've located the solar panels where we would not have shading.
Okay. And so would there still be, it looks like at least on one of the buildings, or maybe 2 of the buildings, I guess, there would still be room for there to be vegetation and stuff. Is that correct?
Yes, the numbers that we shared with our consultants as they ran the areas excluded the pieces of the roof that we were intending to be vegetated. So those are not calculated as part of this and still intended to be vegetated roofs, a tray system, a green roof.
Okay.
Yes.
Thanks.
And I just wanted to add that we still need to look at the structural capacity of the roof. We're actually meeting with structural engineers tomorrow to talk about that, among other things. So, we need to better understand what the existing roofs can support. We understand that The building code has increased over the years from the time that these buildings have been built, and the snow drift requirements have increased. So we need to see if we can actually carry the load on these existing buildings. And if we can't, then the only way we could do that is to build some sort of structure on top of it. So that's a cost that we haven't included yet or is not represented here. And I know when we look at the historic building on the other side of the canal, anything projecting above the parapet would probably be a problem. So there's some work we have to do to get back to you on that.
Okay. We'll hear about that in November? Yeah.
Yes.
Thank you.
Thank you. Mr. Mayor.
Thank you. We realize we'll have a savings with the solar panels, but when Councilor Kennedy brought up about the idea of going green, would we realize any benefits financially by having the building go green? In other words, you know, whether it's from the state or federal government, to realize other monies for doing that?
Well, the building is going to be designed green. That's one of the requirements of MSBA.
Yeah.
We need to meet certain criteria, and we had always been targeting LEED silver on the
But if we went an extra step, I'm just saying if we go an extra step, well, you know.
That's something that would need to be looked into. We're actually be looking at that as we move through the SD to find out, you know, whether it makes sense to do that or not. There's an upfront possible cost to that, so we just need to understand what it would mean to go from silver to gold. In some brand new construction, it's easier to accomplish that. So, for example, we may be able to achieve a higher rating in LEED on the west side of the canal than we could possibly achieve on the east side of the canal, because we have to deal with so many existing conditions that we can't change.
I mean, if I was doing something like this at the house, I'd realize tax credits and those type of things. So we're not looking basically at tax credits, but we're looking at any other way of saving financial. So if you can look into that, I mean, just to give us an idea, you know, a direction that we could go in, especially.
Sure, and we're also going to be meeting with National Grid, and so we'll be strategizing with them as to what's appropriate, and they oftentimes will contribute to strategies in that area as well.
Yeah, thank you.
Sure.
Thank you. Any other questions? So does that conclude our presentation?
Next steps?
Yeah. Yeah, if you want to run through those, that would be great.
Sure. Yep. So just to quickly go through this, our next meetings that will be taking place over the next month, we have 10/9, we have a landscape meeting with the city, and 10/16, we have a potential second focus group meeting with staff. We still have to confirm that time. On 10/18, we have a civil meeting with the city, our civil engineer. We'll be reviewing water utility, wastewater, and with the city engineer and DPW and Conservation Commission. On 10/23, we have a meeting with National Grid. So we'll be meeting with them, as I had mentioned. And then on 10/23, we also are meeting with the working group. We'll be looking at the site plan. We'll have a follow-up to our HVAC conversation and with life cycle analysis. And we'll also be looking at energy. And of course, the next SBC meeting is on 11/1.
Thank you. So just a couple of announcements. As you can see, there's a lot of content and information that is coming to us at each of these meetings that are going to be critical as we have to make decisions, which will be actually in the near future when you think about it. You have on your desk a presentation that we will be getting before the next meeting at 5:30 on November 1st. This is concerning the method of construction, and this is what is known as the CM at risk method. It's different than what has been done in the way past when we did schools. We did design, bid, build, and the construction company or manager came on later in the process. This process is one that was allowed under statute some years ago, and one that many school projects are using now. So we're going to have a presentation so you fully understand that. At some point, we will have to vote on which process we want, and Skanska will be presenting on November 1st at 5:30. And then the other question we'll be circulating to the school building committee is currently our school building committee meetings commence at 6:30. We're going to poll whether people prefer an earlier start time, if you prefer a 5:30 start time rather than 6:30, because we're going, between now and February, we're going to have a lot of information coming to us. So that will be, we will just want to make certain that everybody can be here for 5:30. But November 1st is 5:30, so we can have time to get this presentation and then go right into the school building committee meeting. So I don't know if anybody has any questions or comments. Well, thank you all. Thank you very much, and thank you, Perkins and Eastman and Skanska and our HVAC. That was quite an education tonight. I realize how little I know about the systems.